Hello, my name is Paul Stevers, and I'm co-founder of Climate Solutions Advancement Network, which is a project of Think Renewables Group. Today, I'm going to outline our vision for increasing collaboration between key stakeholders to facilitate large-scale climate action. The world is getting warmer, and there's not nearly enough action being implemented to limit this warming. For example, in October of 2022, the UN warned that the world faces a 2.8 degree warmer future by 2100 if countries continue with the current action gap. A 2.8 global temperature rise from pre-industrial levels is predicted to cause climate catastrophe, which would include much more severe droughts, storms, floods, wildfires, forced migration, and conflict than what is occurring at this time. At the same time, there is enough technologies and funding to implement climate action on a sufficient scale. Unfortunately, instead of collaborating to implement climate action on a sufficient scale, some key stakeholders spend significant resources opposing each other, which is allowing an ongoing rapid rise of greenhouse gas levels. Fortunately, human security experts, or in other words, military and intelligence experts, can help bridge the gap between believers and doubters on the need for large-scale action on climate change. I have observed that most people are particularly sensitive to issues that affect their personal security and that of their families. As a result, human security experts can help focus the attention of key stakeholders on issues that climate scientists are very concerned about. To encourage collaboration between key stakeholders to facilitate large-scale climate action, a series of briefings could be hosted for these stakeholders, where one or more climate scientists would explain a major climate issue, and then one or more human security experts would explain resulting impacts on human security. For example, a glacier scientist could explain the expected global sea level rise, and then a human security expert could outline the associated expected impacts on human security. The key stakeholders would include senior people from industrial sectors with high emissions, the financial sector, governments, and the environmental movement. This briefing would be followed by a set of roundtable sessions where key stakeholders could discuss how they can work together to implement large-scale action. The next set of slides would provide a concise summary of these topics, along with some information about rising demand for fossil fuels and what can be done to mitigate emissions on a large scale. Shown here are some facts about rising sea levels and their impacts on human security. First, the ocean currents have shifted so that now massive amounts of relatively warm seawater is rapidly melting several glacier ice shelves in the Antarctic. Next, melting ice shelves enable glaciers to flow into the ocean significantly faster, causing global sea levels to rise more rapidly. As the UN Secretary General Antonio Guterres indicated, rising sea levels threaten a mass exodus on a biblical scale. Recently, a major new study was completed on the impact of rising seas, which has found that about twice as much land in developing nations will be swamped by rising seas than previously projected. This is expected to affect about 900 million people living in coastal areas at low elevations, which will likely lead to large-scale instability and conflict. Shown here is an example glacier problem. The Thwaites Glacier is also known as the Doomsday Glacier. It is about the size of Nebraska and slowly flows into the Southern Ocean. Currently it is held back by the Thwaites Ice Shelf, which is braced by the seafloor along the grounding line and by underwater mountain peaks in the sea. However, the shelf is fragmenting and could lead to its collapse. If this occurred and the glacier flowed into the ocean, the global sea levels would rise about 65 centimeters, or about 2 feet. I encourage everyone to take a hard look at the current reality about increasing demand of fossil fuels and its impact on atmospheric CO2 levels. Recent reports indicate that the total energy demand is growing faster than renewable energy. For example, in July 2021, the International Energy Agency, or IEA, reported that global electricity demand is growing faster than renewables, driving a strong increase in generation from fossil fuels. OPEC estimates that oil demand to increase to 110 million barrels per day by 2045, up from 97 million barrels per day in 2021. Demand for natural gas is also rising. It should be noted that IEA expects a decline in fossil fuel demand if promised policies by countries are implemented, but apparently OPEC is not expecting this to occur. Some developing countries are rapidly increasing emissions, such as India, which is reported to be emitting more than all of Europe combined. Recently, it was reported that India predicts a 500% increase in its domestic natural gas demand. The net result is that the global CO2 continues to rise at a rapid rate. Shown here are two graphs from the Mauna Loa Observatory in Hawaii showing rising atmospheric CO2 levels. The one on the right shows the rise in the last 63 years, and the one on the left is shorter time scale showing the rise in the last 5 years. The red line shows seasonal variations, and the black line shows a moving average. As you can see, atmospheric CO2 levels continue to rise at a rapid rate. As a result of rapid innovation in a wide range of technologies, increased impact of combining complementary technologies, and development of several nature-based solutions, an opportunity has emerged to implement global emissions mitigation on a very large scale. Given below are some examples. First is the new fuel cell technology that can be fitted to coal plants that utilizes natural gas to power capture of 90% of the CO2 produced and enable this plant to generate 80% more power. Second is a biomass power plant combined with renewable energy farms and an energy storage to produce reliable electrical power, biochar, and renewable fuel. There is a considerable number of climate solutions that mitigate climate change and have considerable co-benefits. We have researched a set of these types of solutions along with their expected impact. If they were implemented in developing countries on a large scale, the impact would be in the range of mitigating 26 billion tons of CO2 per year. Some of these solutions are from Drawdown Lift Initiative by Project Drawdown, which advocates for climate solutions that have multiple benefits for boosting the well-being, strengthening resilience, and contributing to poverty alleviation. Now I want to show some more information about two climate solutions that were mentioned in the previous slide. Here is the first one in an image by its developer, Fuel Cell Energy, which illustrates a coal plant fitted with a specially designed fuel cell that utilizes natural gas to capture 90% of the CO2 produced and generate 80% more power. The information about the second one is a simplified schematic of a facility that combines a biomass fuel power plant, renewable energy farms, and energy storage to produce reliable electricity, biochar, and renewable fuel. About half of the carbon from the biomass is converted to biochar that can be placed in soil to make it more productive. When placed in soil, it remains in this soil for hundreds of years, which enables the process of producing and utilizing biochar to become an internationally recognized way to sequester carbon. As a result, this facility effectively produces carbon-negative energy and can earn carbon credits for the biochar produced, in addition to being able to sell this biochar since it is a valuable soil additive. Since the biomass fuel power plant continues to provide electricity when wind and solar does not, substantial reliable power can be provided to the grid with this system. Any surplus power that is not provided to the grid can be used to convert CO2 from the biomass power plant into renewable fuel, such as renewable natural gas, diesel, or jet fuel. On the next slide is shown an animation of a new integrated cost-effective carbon capture and conversion system by Pacific Northwest National Laboratory that can capture CO2 from flue gas and produce methanol very cost-effectively.
What if we could capture carbon dioxide from power plants across the world? And what if we could convert that CO2 into something useful? These ideas are not new, but combining both steps into one, that's new. Scientists at Pacific Northwest National Laboratory achieved this milestone, and in doing so created the most affordable carbon capture and conversion system to date. Here's how it works. The system takes flue gas from power plants and strips out CO2 using a patented PNNL-developed solvent. The solvent then carries the captured CO2 to a reactor, where it is converted into methanol, one of the most widely produced industrial chemicals on Earth. This continuous process skips multiple expensive steps to release, compress, and purify the CO2. By eliminating the need for two separate plants and shipping and piping the CO2, PNNL has significantly reduced the cost to make renewable methanol. Plant operators could sell the methanol to cover the cost of capturing and converting the CO2. Capture and conversion is not CO2 negative. Carbon in methanol is still released when burned as a fuel, but it can also be reused to produce polymers and products with longer lifespans. Demonstration of this first integrated carbon capture and conversion system holds promise for producing additional chemicals and materials from waste CO2 and reducing emissions.
Demonstrate the benefits of biochar produced by the facility shown in an earlier slide. Shown here is a photo of a research plot that the Norwegian Research Council created in 2014 to measure the agricultural effects of various levels of biochar that has been placed in the soil. As you can see, the addition of biochar increases the growth of crops. Therefore, in addition to being a good way to sequester carbon, placing biochar in soil helps grow more food. There are some major factors that appear to be reducing popular support for large-scale climate action in Canada. This includes the following. First, the day-to-day economic problems of the average Canadian, including rising borrowing costs and inflation, appear to be causing many of them not to prioritize climate issues over other issues these days. These economic problems are compounded by multiple social problems that are affecting many people, such as drug addiction, which are further reducing support for large-scale climate action. To view more information about these society problems, you can click on the link shown on this slide to view a document that contains links to documentaries and articles that explain a range of social problems that are affecting society, especially the younger generation. Lastly, climate misinformation is reported to be surging, which is creating more climate change denial and encouraging the spread of conspiracy theories that lowers trust in climate science. The Liberal government in Ottawa has invested considerable effort in their climate action agenda, but this effort does not appear to increase their popular support. For example, shown on the left is a graph of a poll of a federal election projection published by 338 Canada on March 12, 2023. Which is indicating that the Conservative Party is leading in the popular support. The image on the right is a graph showing a rapid rise of climate skeptic tweets. To implement climate action on a sufficient scale, there needs to be effective collaboration between key stakeholders. This includes implementing innovative solutions on a very large and rapidly growing scale to meet the goals of the Paris Accord. The key stakeholders that need to collaborate include the industrial sectors, including the oil and gas sector, the financial sector, governments, and the environmental movement. To encourage this collaboration, glacier scientists and human security experts can brief these stakeholders on the facts about rising global sea levels, along with the current and expected impacts on human security. In order to rapidly implement projects on a large scale, full engagement of the environmental movement is needed. For example, many large-scale projects have been stopped or delayed due to opposition from environmental groups in the approval process. To shorten the time needed for approvals, early and ongoing engagement of the environmental organizations is recommended to help ensure large-scale projects are approved and implemented in the most environmentally responsible and timely way. Since there are many differences of opinions amongst environmental organizations, to help build consensus for a specific large project, considerable discussions amongst these environmental organizations are needed. Although full consensus amongst environmental organizations is unlikely, the process will help create more understanding of the reasons why a large project should move forward. Given below are some key conclusions from this presentation. First, ocean currents have shifted so that now massive amounts of relatively warm seawater is melting several glacier ice shelves in the Antarctic at a more rapid rate, leading to a faster sea level rise. As UN Secretary General Guterres indicated, rising sea levels threaten mass exodus on a biblical scale, which will lead to large-scale political instability and conflict. Even with the rapid growth of renewable energy, fossil fuel demand is rising, which is continuing the rapid rise of atmospheric CO2 levels. Technologies exist that can be implemented on a massive scale to sufficiently reduce emissions. In order to implement sufficient large-scale climate action at a fast enough rate, key stakeholder collaboration is needed. This includes full engagement of the environmental movement to enable rapid implementation of large-scale climate action-related projects. To scale up climate action, I recommend the following. First, to encourage collaboration between key stakeholders, including environmental groups in the fossil fuel sector, host a series of briefings for these stakeholders, where climate scientists explain major climate-related issues such as sea level rise, and human security experts explain the resulting impacts on human security. These briefings should be followed by roundtable meetings where stakeholders can discuss how to overcome obstacles and move forward on large-scale climate action projects. These industrial sectors, including the oil and gas sector, should propose large-scale projects on a sufficient scale to help countries meet their commitments to the Paris Accord. To help ensure large-scale projects are implemented in the most environmentally responsible way, environmental organizations should engage early with these projects. Since there are many differences of opinion amongst environmental organizations, they should engage in considerable discussions amongst themselves to help build consensus on the best way forward regarding these large-scale projects. Thank you for taking the time to view this presentation. If you are interested in more detailed information, including any links and information mentioned in this presentation, please visit climatesand.org/ICCA. Thank you.